to explain the way to do activity 11. Okay, firstly in Crocodile you have to drag the parts you need here: electronics, analog, power supplies, battery, now switches, single pole, single throw, 1, 2, 3, now bulbs. Here inside the folder, light outputs. You can copy and paste components if you prefer. Copy, then right click and paste. Maybe it is faster if you have to rotate the component. Okay, now I'm going to connect everything. I need one more switch here. Remember to use labels. Here inside presentation, drag text. There's one, and in properties I'm going to choose transparent and no border. Here, copy, paste, paste. This will be S2. This will be S3. Okay, so I think everything is finished so far. So if you take a look to the table, you can see the first state is with all the components, all the switches, sorry, open, 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 open. Bulb for the first voltage. If you hover here at one end of the first bulb, you can see that voltage is 9 and at the other end voltage is 6. So the difference in voltage is 3 volts. 9, 6, 3 volts. So there's no difference between hover to see the values of voltage and use a voltmeter. Here in electronics, inside meters, you have voltmeter. So if you connect a voltmeter here and here, the measurement. Okay, it is -3 because the polarity is inverted. Okay, like this. Now, 3 volts, okay? So there's no difference. You can hover to see the values and to know the difference in voltage, or you can use voltmeters to know the value of the voltage. Okay, in the same way you can use here an ammeter, and as I say, there's no need to use these meters. Okay, once again I have to change the polarity. Like this. Okay, so current is 30 milliamperes, and the voltage for the first one is 3. The voltage for the second one is 6, 3. So the difference between 6 and 3 is 3. For the third bulb is 3 volts, 0 volts, so 3 volts. Okay, with this data, we can fill in the table. So voltage for the first bulb, 3 volts, 3 volts. For the second one, 3 volts. In the third one, bulb 1 current 30 milliamperes or 0.03 amperes. Would you prefer? Okay. Now, second scenario. First one, second one open, and the third one closed. By closing the third switch, we are applying a short circuit for the third bulb. So current is following this way, crossing the first, going through the first bulb, the second bulb, and then from this spot, current is going upwards, passing through the third switch. So because of this bulb is not working, okay, completing the way, the path to the negative pole of the battery, following this way, okay. So now these 9 volts are being shared out between these two bulbs. So 9 volts, the two bulbs are exactly identical, so 4.5 volts for the first one, 4.5 volts for the second one. Since we have less resistance, because now we have only two bulbs working, current will be higher, okay? Instead of 30, 45 milliamperes. Okay, so knowing this, you can check the values hovering once again around this spot, 9 volts, 4.5, so the difference is 4.5, 4.5 and 0 volts, and current is the same for all of them. So here current is 45 milliamperes, as I can read here in the ammeter. Okay, so voltage 4.5 volts, 4.5 volts. I'm going to change this. Okay. And what is the voltage for the third bulb? So here the voltage is 0. Here the voltage is 0. So the difference is 0. In fact, bulb number 3 is not working because of that. Okay, so 0 volts, current 45 milliamperes, current 45 milliamperes, and 45 milliamps. Okay, okay, you have to continue filling in the table following the same way to proceed. Okay, okay, see you soon. Bye.